Yeah, I will discuss about chapter 6. Okay, let me share my screen with you. So this week is week 6, right? So we need to discuss about chapter 6. Okay, let me go to the textbooks and go to chapter 6. Yeah, last week we discussed about chapter 5, right? Chapter 5 is about the discrete probability distribution. Okay, and for chapter 6 we discussed about continuous probability distribution. Chapter 5 is we discussed about binomial distribution, right? Okay. So yeah, chapter 6 is talking about continuous probability distribution. Okay. You can see here chapter 5 is talking about the binomial experiment. Okay. First is we call it uniform distribution. Okay. Uniform distribution is like this. For example, in a situation for waiting motor train, right? Okay. So the waiting time is the same. Okay, like from so this is like waiting time. The waiting time is 10 minutes. Okay. So for example, you want to know what is the you have the same height, right? Okay. You can see the probability here is 0.1. Okay. So like from here to here is 0.1, from here to here 0.1. So if you add all of them together, you got 1. Okay. So if you have some distribution like this, right? For example, you want to find what is the probability that you have to wait between 5 to 10, so between this one to this one. So the same as you subtract 10 with 5, so you got this distance, and then divide by total, which is 10. So you have so you have this one here. Okay. So the answer is 0.5, right? Because the height is 0.1 and the length is 5, right? 1, 2, 3, 4, 5. So 0.1 times 5, the answer is 0.5. So this is one example of the uniform distribution. Okay. For example, you're looking for what is the probability less than 5. So that means you need to multiply the height, which is 0.1, and how many the time here? 1, 2, 3, 4, 5, right? So the answer also 0.5, okay? Because you multiply 0.1 with 5, you got 0.5, right? Okay. Yeah, so this is another example here. You can read it, okay? And the next problem is the section point 6.2 graph of normal distribution. Okay. So they have a common feature like this. Okay. So so the normal distribution just look like this. Okay. So this is we call it failing. Okay. So like first is a from cap up, and then start from this is from sigma. Sigma is like the inflection point or the transition point. and the distance from here to here is considered as the standard deviation. Okay. So start from here is concave up, and then start from here is up to here is concave down, okay, and then concave up again. Okay. And also you can see this is actually is never touch the horizontal axis. Okay. Yeah, so this is the function. And this is the probability of event, like from A to B. Yeah, I think you remember this. This is we call it empirical rule. Okay, empirical rule is like this. So from here to here, we call it the one standard deviation. So from the right to the left is one standard deviation, and from here to here is we call it two standard deviation. From here to here, we call it like three standard deviation. Okay. So you can see this area from here to here is equal to like 68%. Okay, so this area is like 68%, and this area from here to here, or two standard deviation, is 95%, and from negative infinity to positive infinity is considered as 99.7%. Okay. Yeah, I think this was the last problem in sector 6. Okay. We'll go back to here. Okay. Yeah, simply like there are two kinds of normal distribution. One is called a standard normal distribution using the z-score. Okay. So in this case, the mu is 0 and the standard deviation equal to 1. Okay. So this we call it normal. I mean standard normal distribution. Okay. And this is the transformation formula. If you want to change from any normal distribution to standard normal distribution, you can use you call it z-score. Okay. Okay. So this is the way how to find like what is the area under the curve. For example, for this one is like for greater than 280. So you used to, yeah, in Excel, if you have a greater than, you have to subtract from 1. Okay. And then this one should be less than, because in Excel, the function for the normal distribution actually looking for the area on the left. Okay. So if you're looking for area on the right, you have to subtract from 1. Okay? Because remember the area under the curve equal to 1, right? You know, one of the condition of the probability distribution is that the summation of the total area of the under the curve is equal to 1. Okay. Yeah, so you can use the what do you call it, the calculator, and also you can use there are two kind of problem here. You can find the area if you know the number, and also you can find what is the number if you know the area. Okay, using they call it inverse normal distribution. Yeah, this one is a normal distribution. So this is the inverse normal distribution. For example, you want, if you know the area, right? Like this one, like 0.1, and this is the mean. This is the standard deviation. Okay, so you can see what is the number here. So this is like problem in. Yeah, you can also use R here. Okay. So as you can see, this R And looking for greater than, so you need to subtract from 1. Okay, so this is the comment of the for the R. And this is looking for the area on the left. Okay. So if you're looking for the area on the right here, so you just subtract 1 with the area on the left, so you get the area on the right. Okay. So if you're looking for area on the left, you simply like put the comment there. Okay. Because the comment is looking for the area on the left. And if you're looking for the area in between, okay, so you need to subtract the area on the left of this number, right? And subtract the area of the left of this number. So you got the one in the middle. You got the area in between. Okay, I think this is for chapter 6, right? Yeah, it's this one is like looking for what is normality. Okay. So you can use the DA calculator and you can plot it and you can see it is the distribution is normally distributed or not. Okay, yeah, so that's all for chapter 6, right? Just looking for the area, and also there is another, yeah, so you want to see the normal, the normal curve or not. Okay. Can you see this one? And also, yeah, so you can, using the gun, you can see if the distribution is normally distributed or not. Or you can use I'll call it box plot, right? Okay. Okay, let's go to the chapter 6 homework. Okay, so we go down here, and you need to open also chapters Excel for chapter 6, right? Okay. Okay, so save it there. Okay, and okay, maybe I need later I put this using the yeah, using this Google Sheet. Okay, so I don't need to change the screen all the time. Okay, so let me all this open, upload, right? And I save it in the download, right? Okay, so that's here. Okay. Now I'm uploading the what do you call it? The Excel to the Google Sheet. Okay. I will share it to you. I will share it with you. Okay. I will share with you. I will put the link to the chat. Okay. Uh, I don't know why this is so slow here. Maybe because the file too big. Okay, here you go. So this chapter, I mean Excel for chapter 6 homework. Okay. Okay, it start from question number 1. Right? Okay. Let me open the MyOpenMath now. MyOpenMath for chapter 6. Okay. Yeah, if you have any questions, just interrupt me, okay? You know, so this week you need to complete chapter 6, and also you need to see, you need to complete also exam 2, okay? You need to exam, okay? Let me open chapter 6 now, okay? And we discuss about the homework, about the problem in the homework. Okay. The time it takes me to wash a disease is uniformly distributed between 6 minutes to 30 minutes. Okay, what is the probability that washing dishes tonight will take me between 8 and 9 minutes? Okay, and keep your answer accurate to decimal places. Okay, so so the time is between 6 to 13 minutes, right? And then you're looking for what is the probability between 8 and 9. Okay, so you can see the difference between these two is 1, right? So and then the difference between these two is 7. So your answer is 1 over 7. Okay, so your answer will be 1 over 7 is equal to, okay, let me find the online calculator here so you can see it. Okay. Yeah, so you have 1 over 7, right? And your answer is how many decimal you need to put? 2 decimal. Okay, so your answer will be, oops, sorry. Where is it? Sorry. Where is it? Yeah, 1 over 7 equal to, sorry, I forgot where is it, the calculator. I think this one, yeah. So 2 decimal places will be 0.14, right? Okay, so the answer here will be 0.14, okay, or 2.14. Okay, so we can, if you want to use the Excel, so you simply go here. Okay, remember the one on the top is 9, 8 to 9, so you need to subtract 9 with 8, right? And the one in the bottom is from 13 to 6, right? So this is 13 and then this is 6. Okay, so the answer is 0.142857, or if you want to put into decimal place, so the answer will be 0.14. Okay. Oh, sorry, I think I need to share with you the Excel. Okay, I mean the Google Spreadsheet. Let me share with you the Google Spreadsheet in the chat. Okay, okay, so you can use it while so at the same time you can use it and working on your own problem. Okay. Okay. Yeah, I will let you use this. Okay. So I put the link in the chat. Okay, so you can use it while listening to me. Maybe you can follow me to for your own problem. Okay. So I put in the chat. Okay, so you can click it and you can access this Excel also. Okay. Okay. So that's number one. Okay. So number one is talking about uniform distribution. Okay. Okay. So now let's go to number two. Number two, all the answers are correct. Okay. So For number 2, all the answer correct. Okay. Next question. Yeah, so the answer, all the answer correct. Okay, so distribution is normal regardless of the shape of the population distribution, as long as the sample size large enough. Okay, so all of this is correct. Okay, so the answer is E. Okay, so for the next question, you're looking for what is the probability for, if you use Z here, then it is standard normal distribution. Okay, so in Excel, and you need to round up to 4 decimal places. Okay, so in the Excel, you need to put, okay, right here. Okay, so TDS normal, S is a standard. Okay, distribution. So the answer is negative. What is this here? Let's see. So negative 0.62, right? Negative 0.62. And this is true because you're looking for less than. Okay. Oops. Wrong number or argument, expected only one. Oh, okay. Yeah, for the Google Sheet, you don't need to put this one here. Okay. So just put it like that. Okay. Okay, so the answer will be this one. Okay. You can right click, copy, and then paste it here, and then round up to what decimal place, right? Okay, so you round up to 4 decimal place. So you got 0.3446, right? Okay. Oops. Less than 0. Oh, someone changed it. Okay. Okay, so this one should be 0.62. Okay. Okay. You just unmute yourself. Okay, if you have any question. Okay. Just interrupt me. Okay. So yeah, apparently I copy someone else. Okay. Somebody did it inside there. Okay. So I think this one should be correct answer. So so this one will be 0. Yeah. Okay. So this one should be the answer, right? Okay. Yeah, you can continue with the next one. So for this one is greater than. Okay, remember if you think about greater than, you need to start from 1, right? Because Excel always looking for the one on the left. Okay, so you get, you looking for Z less than 0.84, so you got the area on the left. Okay, if you subtract 1 with the area on the left, you got the area on the right. Look at this one. Okay, let me show you how to put it in Excel. Okay, let's go to number 4. Okay, you can see here, if you click this, you can see that I subtract from 1, right? Okay, and I need to put what here. So someone want to be volunteer here? Okay, so 0.84, right? Okay, so I can put the 0.84. So this will be my answer. Okay. Or you can do the same thing. If you put like actually the area greater than 0.84, the same as the area less than negative 84. I mean 0.84. Okay. So this one will be 5, right? Okay. Yeah. Yeah, that's it. Okay. Okay, for this one, so for this one, remember you need to subtract the area of the left of this with the area on the left of this number, right? Okay. So in Excel, you need to put, okay, so that's number 5. Okay, so you need to erase the true here because in Google Sheet, you don't need to put this, okay? It's like automatically you're looking for the cumulative distribution. Okay, so the one on the right will be the first number here, okay? So in the problem here, in this problem here, will be 0.49, okay? So 0.59 first, right? 0.59, subtract with, sorry, 0.49 subtract with 0.49 subtract with the area on the left of negative 2.02, right? So this is 49 and this is negative 2.02, right? So this is will be the answer. This someone else change this one. Yeah, okay. Someone else change that one. uh, yeah, so this one should be, yeah, maybe you can do this. Okay, don't use this. Maybe if you want to work on your own, you can make a copy and use the copy for your problem. Okay. So this should be 0.49, right? Okay. Yeah, please make a copy for your own, okay? And use your own copy to work on your problem, okay? Or if you want, you can volunteer, okay? And solve for your own problem. So this will be copy and then paste it here. Uh, so in this case, it didn't say anything, okay? So you can copy, paste, and submit it, okay? Okay, so, and number 6. Okay, for number 6, you can see here, you know the probability, right? But but you didn't know what is the number here. So you have to use we call it inverse, okay? Inverse the standard normal distribution, okay? So in Excel, you can use this command here for number 6, right? So yeah, I think someone, okay, should be done here. Okay, what is number that you have? 0.36, and probability is less than. So that means you don't need to subtract from that, right? Okay. So the answer will be 0.36, yeah, 0.36, and this will be answer for the problem there. Okay, here. And you need to round up to decimal. So your answer will be negative 0.36. Huh. Almost the same number. Okay, interesting. Okay, so this number 6. Let's continue with number 5. Wow, we have a 26 problem. Okay, so we maybe you need to hurry. Okay. Okay, so So now the probability is for the area on the right of the C, right? And what is C? Okay. So you can use the same command using the inverse command, okay, or inverse function, okay, to find what is this, the number here, okay. So because this is on the right side, right? So that means you need to subtract by 1. I mean, you need to subtract this from 1 in order to get the C, okay. Okay, so what you get here? This number, right? And okay, number 7. So number 7 greater than, okay. So yes, you can replace this. That's why you need to start from 1 as you looking for the greater than, right? Okay. So you need to go put it here. So copy here, enter. So this will be answer. Copy and paste it here. 2 decimal. So your answer will be 1.65, right? Okay. Okay, so number 7, number 8. Okay, so in this case, you're looking for the area in between negative 2.917 and 2.917, right? And because you're looking for percentage, so you multiply by 100%, okay? Okay, so this is the number you need to put there, okay? 2.917, right? Okay, this number 8. Okay, so yeah, again, this you need to remove this. .217, right? And this is minus, oh, sorry, 0.217. And you don't need this one. Enter. And you can see here, for this one, you multiply by 100, right? So you got this number here, okay? Should be here. It didn't say anything, so just copy and paste it, okay? Oops. Oh, sorry, negative 2.917. Okay. Sorry, so it should be 2.917. Okay, 2.197. Negative 2.917. Okay, you can copy this and paste it. Okay, so then number 8. Okay, let's go to number 9. Yeah, it's almost the same thing, right? Okay. So you need to change this. Okay, hold on. You need to be careful here. About how many percent the area under the curve of the standard normal distribution is outside. Okay, outside interval of this. Okay, so because it's outside interval of this, what I mean is, what you need to do. You see, the area is symmetric, right? So are you looking for? Okay, I will show you the graph here. Okay, what does this look like? Let me share with the whiteboard. Okay, so Can you see my what? So this is like this.
Yes, we can see it.
Okay, sorry, this is a normal distribution, right? So if this is the area, negative C, this is C, right? So the area outside of this, the area outside of the one in the middle will be this area. So you can see because the area is symmetric, right? So if you're looking for, if you can find this area, if you multiply by 2, so you got both sides, right? Okay. So you can do is in the Excel, you can do like this. Okay. So in the Excel, you just simply looking for the area on the left of this, multiply by 2 and multiply by 100, right? Okay. Yeah, you can see here, this is the formula already put it here, okay? Negative 1.48, right? Negative 1. And then multiply by 2. Okay. And okay, I think I need to erase that through. Yeah, you don't need to have this. Okay. If you're working on the Google Sheet, you don't need to have that through. Okay. And now as you multiply by 100, you got this number. Okay. So your answer will be this one here. Copy and paste this here. Okay. Didn't say anything, you just need to copy and paste it. Okay. Okay, so it's number 10, I mean number 9, and then number 10, okay. Okay, for this one is, do you know the area between negative B and B, which is this one, okay? But you didn't know what is the B, okay? So the way to do it is you need to find what is the inverse of this, right? Okay. Remember, you can only find the area on the left, right? So in order to find the area on the left, right? So you need to subtract 1 with the area in the middle, right? So you got area on the outside, like I saw you before in the what do you call it? In the whiteboard, right? Okay. So you need to subtract this by from 1 and then divide by 2. Okay. And then you can use it to find what is the p. Okay. I will see this in next slide. Okay, let me copy the area here. Oops, sorry. I cannot create. Okay. 0.9152. So for number 10, yeah, actually it's a wrong process right there. Okay, so maybe just put it inside here. Okay. So first you need to subtract from 1. You need to subtract from 1 with 0. Yeah, you need to subtract 0.9152. 0.9152. Okay, so if you subtract 1 with the area in the middle, you got the area on both sides, right? But now you're looking for only area on the left, right? So you need to subtract, you need to divide this by 2, okay? And because the number that you get from here will be negative, so you need to put negative sign on the front to make it positive, okay? So this is will be your answer for the B. Okay. Copy and then paste it here. and something like that. Right? Okay, so next. Okay, for this one. Okay, so the question is what percent of data point will fall in that range? Okay. Yeah, so the same thing. Okay. So you need to subtract the area on the left of this with the area on the left of this, right? And then multiply by 100%. Okay. Enter number between 0 to 10, not 0 and 1, not 0 and 1, and then not to decimal place. Okay. So looking for the area between these 2 points, right? Okay. So this number 11. Okay, so the area between this, yeah, you don't need to have to true, okay, for the number for the Google Sheet, okay. And you need to change the number 1.7 after that. Yeah, 1.7. Okay, so you need to replace this with 1.7. So you need to subtract the area on the left of 1.7 with the area on the left of negative 1.7 and not to get the area in between. Okay. Enter. Okay, so this will be the answer. Copy and then paste it here. Enter. Okay. And number 12. Okay, so you can see number 12 will go back to the uniform distribution, right? So first you need to find what is the total. The total will be, you need to subtract 52 with 50, right? And then you're looking for what is the probability less than 51.2, so you need to subtract 51.2 with 50. Okay, so subtract 51.2 with 50, divide by 52, divide by 52, subtract with 50, right? Okay. Uh, okay, so you have number 12, right? So number 12 here. So you have 51 over, and then you have 52, 51.2, right? Okay. Subtract with 50, okay. And you got 0.6, okay. So the answer here will be 0.6. Okay. Yeah, so Amanda Stotter knows that the atom have normally distributed lifespan with the mean this and the standard deviation this one, okay. And if you randomly purchase one item, what is the probability it will last longer than 1 year? Okay. That means looking for the probability of greater than greater than greater than 1 year, right? Okay, so you need to change to z-score first, right? So you subtract this with the mean and divide by the standard deviation, right? Okay, and because it's less than, so you need to use the 13. Let's see. Yeah, so because the problem is less than, so you don't need to subtract from 1. Okay, so maybe I put it here. Okay. So because it's less than, so you don't need to subtract from 1. Okay. Oops, sorry. Uh, okay, you need to use norm. norm as distribution, right? Oh no, I think, yeah. Okay, I think in this case it's not normal distribution. Okay, it's just. I mean, not normal standard deviation. It's just simply normal distribution. So you can pick this one. So less than 1 year, that means you need to put 1 here. Okay, and what is the mean? The mean is 2.1, and the standard deviation 0.6, right? So the mean 2.1, and the standard deviation 0.6. Okay, enter. Oops, that one here. Okay. Oh, okay. I think, yeah. Okay. Okay. For this one, you need to put through. Okay. I don't know why. Maybe for standard deviation, you don't need to put through, but for this one, you need to put through. Okay. Okay, so this will be the answer. For less than 1, you don't need to subtract from 1. I mean, yeah, for less than 1 year, you don't need to subtract from 1, right? Is that right? Let me go back here. Yeah, less than, it will last longer than 1 year, right? Yeah, that means it's less than 1 year, right? Okay. Yeah. Oops. Okay, hold on. The property it will not. The property will last longer than 1 year. Oh, okay. Okay. Last longer, that means it's greater than 1 year, right? Okay. So I think you need to use this formula, yeah. Okay. So you need to put this. So you need to start from 1. Okay. So, and then this one is 2.1, right? And this one is 0.6. Okay. Yeah. Last longer, that means it's greater than 1. Okay. Last longer one, that means it's greater than 1. Okay. So you need to subtract from 1. So yeah, so this will be answer. Yeah, so last longer than, that means greater than. Okay, so that's why you need to subtract from 1. Okay. You can see here, subtract from 1. Okay, let's go to number 14. Number 14, for the Excel, looking for the area in between. So you need to subtract the area on the left of this with the area on the left of this. Okay. Let me see what is the problem here. Number 14. Okay, so yeah, the area on the left of this, subtract with the area on the left side, and then get the area in between of this two numbers. So you have 755, right? So you have 755, and the mean is 664. 664, and the standard deviation is 30%, right? Yeah, the standard deviation is 35, okay, and the area on the left is 699. So this one should be 699. The mean is 664. The standard deviation is 35. Right? Okay. Yeah, 664 and 35 and 699 755 755 699. Okay. Okay, so this should be the answer. Copy and then paste it here. Submit. Okay. Okay, a particular fruit with are normally distributed with the mean this and standard deviation is this, right? If here's 6% of fruit weighs more than how many grams? Okay. So in this case, you know the probability, but you didn't know what is the number. Right? Okay. So because it's more than, so that means you need to subtract from 1. Okay. So in this case, the probability will be 94% or 0.94. Okay. So you need to go to number 15. So you need to put 0.94, right? Because you have 6%. And what is the mean? The mean is 448. The standard deviation is 6, right? 448. And the standard deviation is 6. Okay. Enter. So this will be, and you need to round up to nearest gram. So the answer will be 487. Okay. 487. 487. Oops. Okay. 448 to this. Okay. 0.94. 4486. Okay. Oh, sorry. I think I put wrong answer here. It should be 457. Okay, sorry. Here you go. Okay. Okay, so this is less than. Okay, so yeah, so this one is less than, this is more than. Okay. Okay, let's, yeah, it's the same thing. Okay, so number 16, the first problem is less than. So this is less than, so that means you need to change this with 339, 33.9. Okay. So you have a 33.9. And the mean is 33. Standard deviation is 84. 84. Yeah. So this is the answer for the first question. Round up to 4 decimal. So this one will be 7, right? 27. And this one is greater than 22.8. I mean 22.5. So this one is greater than 22.5. Oh, sorry. And then the mean will be, okay, what is, okay, the mean is 33. 33. Standard deviation 8.4, right? Okay. So this will be the answer for the second question. And again, you need to round up to decimal place, 4 decimal place, right? Okay. So the answer will be 4, yeah. So this number 16. And so distribution value now is okay. The mean days, the standard deviation days, find what is the P, which is the score separating the bottom 28% from the top 72%. Okay. So, and then you need answer accurate to 1 decimal place. Okay. Yeah, so you need to find what is the number, right? That separate the 28% from the top, separate the bottom 28% from the top 72%. Okay. So it's simply using the inverse and put this and put the mean and the standard deviation, so you get the number. Okay. Okay, so you need to put this number times something, right? Okay. So it is 28, right? The mean is 90. The standard deviation, the mean is 90, and the standard deviation 18.2. 18 point, enter. And you need to round up to 1 decimal place. So the answer will be 79.4, right? Okay, so the number 17. Let's go to number 4. Yeah, so this is the same thing, right? Okay, so you need to find what is the area on the left of this. But you need to multiply by 100 in order to get the percentage, okay? Okay, so you need to put this number first and then the mean and the standard deviation, right? Okay. So number 18, 1305, 1305. The mean is 1455. And the standard deviation is 301. Okay, so this will be the answer. Okay, hon, I think you need to be careful here. And your problem is less than, so that means you don't need to subtract from 1, okay? But the problem in the Excel is greater than, so you need to subtract from 1, okay? So for your problem, so you don't need to subtract from 1, okay? So you need to erase this. So that will be answer for less than 1305.
Did you say it doesn't have to be subtracted by 1?
Because it's less than. Okay, okay, so I need to multiply by 100, okay? Yeah, as you multiply by 100, so the answer will be 30.9, right? Yeah, 30.9. Okay, so as you multiply by 100, if you put in one decimal, so the answer will be 30.9. Okay. Yeah, I think I need to put, for this one, I need to put multiply 100. Okay. Okay, hold on. Maybe I need to differentiate this. Okay. Control C. Okay, so you need to subtract from 1 if you have greater than. Okay. But if you have less than here, I don't know what this is here. Let me erase it. Okay. Oh, this is the percentage. Okay. Okay, so for the problem, oh, sorry. Okay, here you go. So for this one is like you're looking for P less than. Okay. So for less than, you don't need to subtract from 1. Yeah, I'll put it there so you can see the difference. Okay. So the answer will be this one because you're looking for less than. Okay, let me see. Maybe I need to put this as like 1305, something like that. Okay, sorry. Okay, so for the 13 or less than 13.5, you don't need to subtract from 1. Okay. Because the Excel always looking for less than. So it's looking for greater than, you need to subtract from 1. Okay, does that make sense? Okay, so now you need to move to the next one. The next one will be number 19, right? Okay. Let's see what number 19 here. Yeah, so if the student get SAT score 58 percentile or 58%, find the actual SAT score. Okay. So in this case, you know the probability, but you didn't know the number. Okay, so you have to use the inverse function. Okay. Okay, so you need to number 19. So this is 19, right? Okay. Yeah, so apparently the percentile is the same. Okay, 88 percentile. But let me see what is the mean here. The mean is, okay, so in this case the mean is 992. The mean is 992. 992. And the standard deviation is 198. 198. So this will be the SAT score for the 58, sorry, yeah, 58 percentile, right? Okay. Let me put it here. We need to put here round answer to whole number. Okay, so if you round to whole number, so this become 1032, right? Okay, and if you want to find the equivalent of the score, so you need to do the same thing, but now you need to put the mean for the ACT and also the standard deviation for the ACT. Okay. The mean is 22.7, the standard deviation is 3.9. To 7, 3.9. So if you're looking for one decimal place, so the answer would be 23.5, right? 23.5. If you have this score, what is the equivalent for the ACT? Yeah, for number C is down here, right? Okay. Yeah, so this is like this. First is you need to find what is the probability for SAT with that number, right? And to find the equivalent, so you need to put norm inverse, and then put the mean and the standard deviation for the ACT. Okay. So inside here, you need to put the SAT number here. 1269, 12, 1269. The mean is, I forgot, 992. 992. The standard deviation 198. Okay, the same, right? Yeah, the standard deviation is 198, the same. And now you need to put mean for the SAT, which is 2.7, and the standard deviation is 3.9, right? Okay, so now put enter. Say you need to put like one decimal number, right? So the answer will be 28.2. Okay. 28.2. Bismillah. Okay, we got all the correct answer. Okay, let's go to the number 20 now. Yeah, so first you need to change the number to the z-score. Okay, so you can subtract this with the mean and divide by the standard deviation. Okay, so that's number 20, right? Okay. Okay, so that's the picture, and this is the z-score here. Okay. So the number that you have here is 91.5. So you have 91.5. The mean is 92.12, I think. I think the mean and the standard deviation is the same. Yeah, 92.12, 22.43. Yeah. Okay, so this is the z-score for this one. And you need to copy this. If you put in 2 decimals, so the answer will be negative point. This is okay, maybe just start with that. So negative 0.26. Okay. Negative. Oh, sorry. Yeah. So negative 0.26. Negative 0.26. Okay. Approximate the what fraction of these four opposing baseballs would you expect to have a speed between 89.6 mile per hour and 91 mile per hour? Okay. So you need to subtract this with this. I mean, you need to subtract the area on the left of this with the area on the left of this, right? And so to get in between. Okay. Okay, so 91. The first area will be 91. I mean, the area on the right will be 91 to the left. And the standard deviation in the same 91 and then 89.6. 89.6. And this will be the answer. But check the second question. Yeah, apparently I cannot copy and paste it. Okay, so you need to round up to 3 decimal place. So the answer will be 0.73. Yeah. 0.73. 0.7. Sorry. 0.173. 0.173. And approximate what's the fraction? I set it to below. So below that means less than. Okay. 89.6. 89 point. Yeah, this is above. So in order to get below, you simply, okay, let me copy this. Okay, so in order to get below, so if you're looking for less than this guy, right? So you don't need to subtract from 1. So in here, you don't need to subtract from 1. And this one will be 89.6 again. 89.6. Yeah, so this will be answer for less than 89.6. Okay, how many decimals to put here? 3 decimals. So the answer will be 0.150, right? 0.150. Yeah, so you can see clear, this is below. So the one in the Excel is above, right? So you need to start from 1. Okay, what is this here? Include the fastest, 21%. Round to nearest 1%. Nearest 1 decimal place. Okay. 21%. The fastest Yeah, so it is the first, that means it's greater than, right? So in order to find the less than, so you need to subtract from 1. Okay, so you have 100%. 21. 21, 100 subtract with 21, you got 79, right? So this one should be 0.79. So if you put one decimal place, so you have 94.1. This is 94.1. Okay. Yeah, I think we got all correct, right? Okay. Okay, let's go to number 21. I think we still have time. Okay. So it's the same thing. Okay, so you can see here, because less than, so you need to subtract from 1, right? Okay. Let's see what is the problem in the exam. Yeah, so this is need to subtract from 1. Okay, so just need to change the number here. Okay. Okay, so for this one, 540. So it is 540. 540. The mean is 494. 494. And the standard deviation is 99. Right? 99. So this will be the answer for the first question. You need to put like 4 decimal place. So the answer will be 0.3211, right? And for this one, yeah, the same thing, you need to subtract from 1, but there's one more thing that you need to put here, which is divided by the number. Okay. 940. What is the name again? 494. 494. The standard deviation is 99. And how many? What is the sample? The sample size or the number of sample? 15, right? So you have 15 here. So you divide by 15. Enter. If you round up to 4 decimal place, the answer will be 0.0359. So you got 0.0360, right? 0.0360. And you can submit the answer. Okay, let's see. Assume that the probability less than 5% is sufficient evidence that conclude that okay. Because this one is less than, so the answer is yes. Okay. Yeah, makes sense. Let me see. Okay, let's go to number 22. Yeah, I think most of you is make mistake for this one. Okay. Okay, so I have to make sure you understand with this. Okay. But this one is the one that the set is in between, right? Should be this one, between two values. Okay. So on the left side, you need to put like negative 2.5. So you need to go to the left like this. Negative 2.5. Okay. And on the right side, you need to go to 0. 0 is this one. So this for number 1. For number 2, you have to use Excel. So in this case, you know the area, but you didn't know what is the C here. Okay. So the one that is set is lack of value. Okay. So now I'm looking for what is the value here, that the area is 0.3. Okay. Yeah. Okay. For make sure you need to use the Excel. Okay. So this number 22, right? Okay. 22, this one. Okay, so because the area is simply less than, so you need to replace this number with the number that you have here, right? 0.3, okay. So you need to put this one is 0.3. 0.3 will be negative, so you need to put, so maybe you don't need to put negative, so C should be negative, okay. Okay, yeah, see the C to be negative because the area on the left side, right? So you don't need to put negative sign there. So the point should be 0.5. Okay, so you need to move this to 0.5 right there. So this will be answer. Okay, this is correct. This is correct. Right? And number 23. Yeah, it's just the same thing. Okay. But let's do it. Okay. So greater than 27.4. Right? 27.4. 27.4. The mean is 28.7. 28.7. And the standard deviation is 16.7. 16.7. Enter. And you need to round up to 4 decimal, so the answer will be 0.4690. Right? 4690. Yeah, so the same thing for this one, just need to divide by the sample size, right? $27.4. The mean is 28.7. 28.7. And the standard deviation is 16.7. And the sample size, and here is 133. Okay. So here is 1, 2, 3. If you're looking for 3 decimal place, so the answer will be 18, 0.185. Oh no, it is for decimal place. Yeah, it seems to be for decimal place. Okay, so the answer will be 0.1847. 0.1847. Enter. Oops, both of them is wrong. Okay, I see now the problem here. This is greater than, okay. So because the problem is greater than, but in this case is less than, okay. So it's just simply subtract with 1, yeah, okay. So this will be answer. Yeah, for decimal place, right? Okay. And yeah, the same thing for this one, you just need to subtract this from 1, okay. So you have 0.8153. 0.8153. Sorry, 0.81. Yeah, so because it's a greater than, so you need to start from 1, okay? Because the problem is greater than. Yeah, maybe I need to put back here. Okay, so now number 24. Is that right, number 24? Yeah, number 24, right, okay. Yeah, it's almost the same thing, okay. The bottom score from the top score. Yeah, it's the same thing, okay. But you still have time, okay. Let me finish it, okay. So you have yeah, you need to put the 694, okay. Yeah, maybe I can skip it, okay. So you can go to the, so they will do the same thing, okay. Let's go to number 25 here, okay. So this is, we call it the empirical that that we discussed earlier in this class, okay. So first you need to put what is the mean, okay. So in this case, the mean is 65, the standard deviation is 10, right? So this is 65. And the standard deviation is 10. And you're looking for the area between 65 and 85, okay. 65 and 85 will be these two areas, right? So the answer simply you add these two, okay. So you get what? 47.5. Okay. You add these two, you got 47.5. Okay. In here. So you replace this with 65 to 85. So you can see you just simply add. Yeah, you can add the one on, so in this case you need to add the one on the left side, yeah, right? So you need to add E13 with F13. Okay. Yeah, you need to add those two areas. Okay. Those two areas. The answer is 47.5. Yeah, so the same thing for the last number, yeah, the last problem. So you need to change the 44 and the standard deviation is 10. So this is 44 and the standard deviation is 10. And you're looking for the area between 54 and 64. 54. So area between 54 and 64 will be equal sum plus. Yeah, 84 and 64. So only this guy. Okay. So the answer is 13.5. Okay. Yeah, we still have we still have time, like 5 minutes. Okay, let me go back to number 84. Okay. So you can see this is the same thing. Okay. So in this problem, the percentage is 26% or 0.26. Okay. For this problem, 92. So 0.92. Okay. So this one should be 0.92. And what is the mean? 49.7. 49.7. And the standard deviation is 25, right? 25. Okay, so how many decimal place you need to put? One decimal place. So your answer will be 84.8. 84.8. Yeah, so this is the same thing. So maybe just copy. Maybe you can use the same. Yeah, you can use the same thing. This one here. So just need to divide this with the square root, right? The square root of the sample size, which is 167. 167. So the answer is 39.0, right? As you were looking for one decimal place, right? Okay, so the last one is wrong. Let me see what is here. Button. Okay, let's see. What's wrong here? Oh, I think I made a mistake. I think to be not this one that you need to divide by. Okay, but this. So it's just not the mean that you need to divide by, right? but the standard deviation that you need to define. Okay. Yeah, so answer will be 52.4. 52.4. Okay, so now we got to answer. Okay, I think that's all for today. Okay, we on time. Like now it's 10 point. I mean 10 o'clock 40 past 45 minutes. 45 minutes past 10. Sorry. Okay. Yes, do you have any question